Hello, welcome to the second problem of B.Stat 2005. This is a very curious graph drawing problem. It basically works with it starts with a integral format. So this is the form of the function that is given to us. And we are supposed to graph that function. So the function fx is given to us as an integral, and we have to find the graph of it, and also we have to find the minimum value of it. So we have already done the first problem in a previous sequence of video lectures. In this one we will try the second one. So let's start with this. The easiest and the most obvious thing to do is to compute the integral. So let's do that. We have f of x is equal to integral of 0 to 1 absolute value of t minus x t dt. Now, whenever you are dealing with a problem of absolute value function, always understand that an absolute value function is basically a piecewise defined function. So this is something you can remember as a rule of the thumb. Absolute value function is piecewise defined. Well, I should say sort of, because this is just a problem solving strategy. So your goal is always to lift the absolute value signs. It's always to lift the absolute value signs by suitably defining the domain. So the strategy, and this is true for all absolute value function problems, is to lift the absolute value sign by suitably defining the domain. And of course, in other types of problems, there could be other strategies of dealing with this. But it's almost always the case that you want to lift the absolute value sign by some operation or other. So in this case, we will do exactly that. We know that t is between 0 and 1. If you look at the uh, upper bound and the lower bound, and if you observe that the integral is done with respect to t, it's clear that t is between 0 and 1. So let's take the different values of x. So let's use a different color, maybe yellow is fine. So we will define separate values of x. So suppose x is less than 0, x is between 0 and 1, and x is greater than 1. And x is between 0 and 1. This is actually the critical case. So we'll have to be careful about this one. X less than 0 is actually quite simple. If x is less than 0, then of course absolute value of t minus x is t minus x. So we will have 0 to 1 t minus x t times dt. So this is simply t square minus xt integral from 0 to 1 dt. So if we integrate it, we will get t cubed by 3 minus x times t square by 2 from 0 to 1. And if you plug in 1 and 0, you will get 1/3 minus x by 2. And of course, plugging in 0 would not give you anything particularly interesting. So this is the function f of x. This is the function f of x for x less than 0. Also, let's deal with the case where x is greater than 1. Then we will take the complicated case, x between 0 and 1. So x greater than 1, that means absolute value of t minus x is equal to x minus t if x is greater than 1, right? Because t is between 0 and 1. So maybe we can use a different color for this particular case. And this is because x is greater than 0 and t is between 0 and x is greater than 1 and t is between 0 and 1. So we can again integrate 0 to 1 x minus t times dt. So let's again open the brackets. So xt minus t squared dt, and this would become x times t squared by 2 minus t cubed by 3, 0 to 1. So this will be simply x by 2 minus 1/3. So this is f of x when x is greater than 1.